I am going to be walking you through the 6 problems on the notes page, how I solved them with the AC method, and the answers that we should get. Here are, before I get to the explanations, here are the answers for each one. You can check your answers right now, but what I'm going to say is look at the timestamps for the explanations for each one. If you got it wrong, don't just accept it and move on. Go to that timestamp in the video and watch my explanation. This is my resource to help you understand, to see an explanation of why your problem was wrong and how you can fix it. This is on you to make sure you understand, and if you just copy the correct answer without actually understanding why this is the correct answer, that's not going to help you in the end. So make sure that you're making a good choice on how to best help you understand this process. Alright, so here's the first problem. The first step that I always follow when I have a trinomial with a number other than 1 next to the x squared, I'm going to check to see, is there one number that I can divide into all 3 of these terms, 2, 5, and 2. And no, there is not a number I can divide into all 3 of these. So I'm going to start off right away with the AC method. So with the AC method, first I need to find what is A times C. In this example, our A is 2 and the C is also 2. So I'm going to multiply 2 times 2 to get AC. To get 4 is A times C, 2 times 2 is 4. Now the second step, I'm going to check to see what numbers multiply to equal 4 and add to equal this B, or in this case it's a 5. So I'm thinking of numbers that multiply to 4 and add to 5. So I'm going to start off with 1. 1 times 4 is 4. Now I'll check to see if those add to 5. 1 plus 4, yeah, that equals 5. So I'm going to rewrite this 5x. I'm going to split it up into 1x and 4x like this. Then so that was the third step. Now the fourth and last step is to factor by grouping. So I'll put it into 2 groups and factor each group separately. So in the first group, looking to see what's in common, there's not a single number besides 1 that can be divided into both, but they do both have an x. So I'm going to factor out an x, and then left I have a 2x, and then a 1. Then the next group, they both can be divided by 2, so then we're left with 2x plus 1. Then to make sure this is completely factored, I'm going to see if there's anything else in common here, and both of these multiplications have this parentheses 2x plus 1. So I can take that out, I can factor that out as well, 2x plus 1, and then we're left with an x and a plus 2. So here is the final factored answer of this polynomial. Next up, we have 6g squared minus 13g plus 6. So first step, we're going to check to see, is there a number I can divide into all 3 of these, 6, negative 13, and 6? And no, there's not anything I can divide all 3 of these by. So I'm going to start off right away with the AC method then. So in this case, A is 6 and C is also 6. So 6 times 6 is 36. So I'm going to be looking for numbers that multiply to 36 and add to negative 13, our B. So thinking through my factor pairs, 36, I could have 1 and 36, but those don't add to get 13. So we'll move on to 2. 2 times 18. That also does not add to get 13. 3 times 12 also does not add to get 13. 4 times 9, 4 plus 9, yes, that equals 13. So I know I'm going to be using a 4 and a 9, but I'm also noticing that this 13 is negative. So in order to make it a negative 13 when I add them, I should have this be a negative 4 and a negative 9. and it still will equal positive 36 since negative times negative equals positive. So now I'm going to rewrite this, but instead of minus 13, I'm going to split it up into minus 4g and minus 9g. So that's step 3. Step 4 is to factor by grouping. So in our first group, 6g squared minus 4g, I'm noticing that both of these numbers can be divided by 2, so I can factor out a 2, and both terms also have a g, so I could also factor out a g. On the inside, we'd be left with 3. 6 divided by 2 is 3. We had 2 g's, we took one out, so we're left with 1 g. Minus 4 divided by 2, 2, and we took out the g. So that's all we have there. Then the next parentheses, both of these can be divided by 3. So I'm going to factor out a 3, and I'm going to make it a minus 3, since it's a minus 9. Then I'd be left with negative 9 divided by negative 3 to get 3g. Positive 6 divided by negative 3 is negative 2. Notice how when I factor out this negative 3, I get the exact same parentheses, which is what we want. If we had the opposites, then we would need to change the sign to make these parentheses be exactly the same. But at any rate, these two parentheses are the exact same, so I can factor out the 3g minus 2. Then we're left with 2g minus 3. So there is our final factored answer for this problem. All right, here is the next one, 2b squared plus 3b minus 6. First step, let's see if there's anything we can divide each of these by. 2, 3, 6. Nope, nothing in common. So I'm going to go straight into the AC method. A, 2, C, negative 6. So I'm going to do 2 times negative 6 to get negative 12. So now I'm going to check what numbers multiply to negative 12 and add to positive 3. I'm going to think of some factors to get 12, and then I'll think about later how to make it negative. First, I'm just going to think about the 12. So 1 times 12. Any way I can make positive 3 with a 1 and a 12? No. 2 times 6. Any way I can make a positive 3 by adding 2 and a 6, positive or negative, either of those? No. 3 times 4. Any way I can make a positive 3, adding up a 3 and a 4? No. And those are all of our factor pairs for 12. So if you go through all of the factor pairs and none of them add up to this b, then this is what is called a prime polynomial. This is when this polynomial cannot be factored. It can't be broken down into a multiplication problem. So this is all we would put for our answer on this one. Moving on to the next one, 9p squared plus 6p minus 8. First check, is there a number that can be divided into all three terms? 9p squared, 6p, negative 8? No, nothing. So let's go straight to the AC method. A times c, in this case, 9 times negative 8 is negative 72. So I'm going to look for numbers that multiply to negative 72 and add to positive 6. So I'm going to start at the beginning, 1 and 72. I'll think later about which one would be positive and which one would be negative to make this be a negative 72. So first though, 1 and 72, when I add those, no way I can make 6. 2 times 36, when I add them, it doesn't make 6. 3 times 24, when I add those, nope, no way I can make 6. Next we'll have 4 times 18, I'm adding 4 and 18, no way I can make 6 with that. Next up 5, and 5 doesn't multiply by anything to make 72, since this ends in a 2. If it could divide by 5, it would need to end in a 0 or 5. So I'm going to get rid of the 5. Next up 6. 6 times 12 equals 72. Any way I can make a positive 6 by adding 6 and 12? Yeah, I know that one of these is going to be positive and one is going to be negative, since when I multiply it should equal negative 72. So I need to decide which one should be positive and which one should be negative, so that way when I add it, it will equal a positive 6. Well, I know that I want to have more positives than negatives, since it should get me a positive answer. So looking at 6 and 12, the 12 should be positive, because that way if I add 12 positives and 6 negatives, it would get me a positive 6 when I add them. Here I just drew a little diagram of that. If you weren't quite sure what I was meaning by that, if we have 12 positives and 6 negatives, they will add to get positive 6, and they will multiply to get negative 72. So I know that the two numbers I'm going to split up 6p into are negative 6 and positive 12. So I will rewrite it to negative 6p, positive 12p, and then we'll factor each group for our last step. So in this first one, a number that they both can be divided by is 3, so I can factor out a 3. I also notice that they both have a p, so I can factor out a p as well. On the inside, I'd be left with 3p minus 2. I'll do the same in the other parentheses, 12p minus 8. Both of these can be divided by 4. Then I'd be left with 3p minus 2. These parentheses are the same, so we're going to factor that out. And I'm left with 3p and a plus 4. So here is the final answer for this polynomial. All right, next one, 3a squared plus 30a plus 63. First check always is to see, is there a number that we can divide into all three of these terms? And in this case, yes there is. All three of these can be divided by 3. So before I move into any other method, I'm going to factor out that 3. So I'm going to take out the 3, and I'm left with a squared plus 30 divided by 3, 10a, plus 63 divided by 3, 21. Now at this point, there's not a number left next to the a squared. It's a 1. We don't have another number, so we actually don't need to do the AC method anymore because there's not a number here. We can just factor this like we first learned how to factor, where we see what numbers multiply to 21 and add to 10. So thinking about numbers that multiply to 21, we could do 1 times 21, but those don't add to 10. 2 doesn't multiply to get 21. 3 times 7, and those do add to 10. So our two numbers are going to be 3 and 7. Here's the final answer there. So in this case, we didn't need to use the AC method because once we took out the 3 from all three terms, we didn't have a number left next to the a squared. And then the last problem for the notes page, 6n squared plus 10n plus 4. First check, is there something I can divide all three terms by? 6, 10, and 4. Yeah, I can divide each of those by 2. So I'm going to take out the 2, and then I'll put what's left. 6 divided by 2, 3. So I'd get 3n squared, plus 10 divided by 2, 5n, plus 4 divided by 2, 2. So now we have 2 times this trinomial, and I'm noticing that this problem is different than the problem before because in this problem we still have a number left next to the n squared. It's not an invisible 1 here, we have another number. So when we have another number, we need to use the AC method. If there's nothing else that can be factored out of all three of these, then we need to use the AC method to see how would we factor this last section here inside the parentheses. So I'm going to think about this part here inside the parentheses as its own thing right now. For now, I'm going to kind of just ignore this 2 until the very end. So the 3n squared plus 5n plus 2, I will do a times c, so 3 times 2 would get me 6. So I'm going to think of numbers that multiply to 6 and add to 5. So 1 times 6, that equals 6, but 1 plus 6 doesn't equal 5. 2 times 3 also equals 6, and 2 plus 3 equals 5. So those are the two numbers we're going to use. So when I rewrite it, I could put 2n plus 3n plus 2, and then I will factor this into two groups. I can take out an n here, and I'd be left with 3n plus 2. Here, 3n plus 2 in this parentheses. The only number I can divide it by is 1. They don't have an n in common, so I can just take out a 1, and I'd be left with 3n plus 2. These parentheses are in common, so I can factor that out, and I'm left with n plus 1. And then the last step is we need to remember that the trinomial that we are factoring, it was not just the parentheses, we also had this 2. So we need to be sure that we include the 2 in the end, because this was not alone, it had a 2 that went with it. So I'll put a 2 at the beginning to multiply it, and here is the final factored answer for this problem.